You're about to watch a video that's going to help your Roblox scripts look way more professional, you'll spend less time debugging your code and more time writing better code. The video is me giving a class to the Premium Scripters Discord community about a book written by an expert software engineer who has 35 years of experience about how to write clean code to save you thousands of hours of debugging. I took all of the concepts and presented it in a way that makes sense for Roblox scripters like you and me. Let's get started. This is a class on the art of writing clean code, and this is probably going to be a shorter class compared to what we had before because, well, there's quite a lot of slides, but we're not gonna spend hours on each slide. But anyway, let's get started. So this is a book called Clean Code, and it's written by a guy called Robert C. Martin, and this is basically like one of the ultimate books on writing clean code. So this whole presentation is going to be based off of this book. And he basically wrote this book using examples from Java. And obviously in Roblox, we don't use Java, we use Lua U. But this whole book is written in Java, and it's got a lot of very valuable concepts to help you write better code. So I basically took all of the concepts here, and I'm going to present them in Lua so that we can use them to become better scripters. And here's the man himself, Robert C. Martin. This guy's the guy that wrote the book. And a little bit background on this guy is he wrote a bunch of books on software engineering. He's the author of Agile Manifesto. And what that basically is Agile is like, it's a method where you just kind of develop software rapidly and you're just working really, really fast to ship features to satisfy clients. But in game development, we're not trying to satisfy clients all the time. I guess our primary customers would be players. So we're trying to satisfy players. So in game development, this whole agile thing that he worked on basically means make a bunch of features, fix a bunch of old stuff, and do it in a fast way and satisfy players. So it's a way of thinking about writing software. So that's what agile is. And maybe one day I'll meet him. This guy sounds pretty chill. Okay. So why do we even want to write clean code in the first place? And the reason that he says is because writing bad code has consequences for us. So if you write bad code, we sometimes we're given a task, like maybe it's like implement this coins feature, and then the task might have a due date of like 2 days. Then we might be facing some adrenaline and we might be like, oh well, let me try to get this feature done in 2 days like the client wants. And the problem with that is we're gonna write a bunch of bad code. If we want something done in like 2 days, then we're probably gonna rush through it. Or like if we're strict on time, then we're probably gonna rush through it and just try to get things done. And that's kind of what bad code is, where we're just trying to get things done. We don't care about anything else, we just want the thing to work. And we do that thinking it will save time because we'll get it done faster, but it actually ends up in us spending more time to maintain it. And it becomes very difficult to add more features. And as your code gets more and more complicated, it just becomes harder and harder to add new features. And what he says is that at some point, the code that you write is so complicated that it becomes so almost impossible to even understand what you wrote. So like imagine a whole giant block of code that's so complicated that you can't even understand what you wrote. Like you're going to be like staring at it for 3 hours trying to figure out how to add a new feature so that you can update your game. And that's not what we want, right? We want clean code. We don't want bad code. So, and why do we write it in the first place? It's basically because of what I said. We write it because we're under strict deadlines by our boss. And the mentality is, who cares if it's clean? It works. And even if it means we're writing bad code, it works, and that's what the client wanted. But that's a bad way to think about things. And sometimes we write it because of a lack of experience. Like if you've only coded for a few months, you might not be able to spot like bad coding practices right away. And sometimes we have insufficient understanding of the requirements. So if someone asks you to code like a combat system, and then they pay you, and then they're like, okay, I want it done in 3 days. Well, you're probably going to work on the combat system, but it's probably going to be written very poorly. And in the middle of your combat system, the person that you're making it for might not actually like it because you just kind of rush through it. You never ask them for details. So what I do is when someone asks me to script something, I have them write down like a 10-page Google Doc or a Word document of every little detail that they want scripted so that there's no questions, there's no confusion. And as I'm coding, I'm looking through this Google document and making sure that everything that I'm coding, it aligns with whatever they want. And that way, they won't just ask you like, oh, can you make a combat system for me? They'll ask you more of like, I want a combat system where if you press E, then they'll punch. And if they punch, then there's this random chance of this happening. And if that random chance occurs, then maybe there's a knockback. Like they'll say things in a way where it's more detailed. And that's kind of what you want. And that way you won't be rushing and you'll actually spend some time with your code. So here's an example of bad code. So here's a whole bunch of things. Does anyone want to point out what might be bad about this code? It doesn't matter what it does. Just like point out line by line, like stuff that you think is bad about this code. And you can just chat it in Discord. Yep, variable names. So this TS right here for teleport service. Imagine you're like writing this code and then like in line 500, you see a random TS. You might not know what it is. Is it tween service? Is it teleport service? Like you'll have no idea what it is. So that's one example of something that you shouldn't do. The variables inside the function parameter. Yep, you got it. Like what is PL? What is ITM? ITM, is that item? Is it like some acronym? Is PL player? Is PL, who knows, right? So that's a whole bunch of stuff. And even the functions themselves, like if I see add, I'm expecting it to literally add, right? Not whatever this is. I can see it's adding some stats, but I don't want to have to think about what this is doing. I want it to just be obvious. I guess the goal would be to write code that's obvious, so when you give it to someone, they'll actually understand what it is without having to squint through each line. So this is what you want to avoid. And here is that same code, but made a whole lot cleaner. So look at what's different. First thing is I've fixed this, the function names. If you look before, TP and add, now there's actual names like teleport player. I wonder what that does. Oh, it teleports the player. Add points and destroy item. Huh, I wonder what that function does. Oh, it literally adds points and it destroys an item, right? So you want to make it as obvious as possible what the function is doing. Right from the name, I should be able to know what it's doing. Like right here, on item touched. Oh, it's when something touches an item. Like I don't even have to read the rest of the code. I can just tell from the function name. Okay, does that make sense? And another thing is this thing right here, which is a whole bunch of variable names that are written in, this is called, I think, Screaming Snake case, where you have the entire variable name is capitalized, and where there would be a space, there's an underscore. This is called a constant. Yep, it's basically settings for variables, but we call them constants, and you'll see why pretty soon. So here's the first principle of writing clean code: meaningful variables. Name your variables so that you don't have to scroll all the way up to figure out what it means. Here's bad code, right? So we have local x equals 5, and then we have a comment that says time in seconds. Okay, so x must mean 5 seconds, and then we have n, which is speed boost. But notice how I needed a comment to explain what x was. Like, someone reading this would need that comment to know what this 5 represented. And we don't want that. We want the variable name to be so obvious that we don't even need a comment to represent what it means. And what happens later if I decide that this x isn't going to be in seconds anymore? What if I want this x to be like 5 minutes? Well, now I have to change a whole bunch of things down the line of my code, and I also have to change this comment. And comments tend to get really outdated, as we'll see. And here is an example of clean code. So now instead of an x, we have boost duration seconds, and we have that set to 5. Look at how different that is. Instead of saying local x equals 5 and then making a comment that clarifies it, we just clarify it right there. So I already know what this variable is. It's the boost duration, and it's given in seconds. And there's a power-up name, which is called speed boost. So the one main thing that I would like everyone to take away from this is make your variable so obvious that if you give your code to someone, they don't have to scroll all the way up to figure out what it is. So that's that. And if the variable doesn't ever change, you want to make it a constant. So right here, this is written in Screaming Snake case, where every character is capitalized, and there's an underscore where a space would be. So base player walk speed is set to 16. And as you can see, I'm setting the walk speed here to whatever that base player walk speed is. So this 16 and this 2 will never change. Like later in the code, I'm not going to say walk speed booster equals 3. That's why we make it a constant. Constant means that the variable will not change. So if you know that your variable isn't going to change ahead of time, make it a constant. And what that basically means is put the variable in uppercase and use an underscore where the space would be. So here you can see, set the walk speed to the base player walk speed, which is 16, and apply the boost, which basically sets the walk speed to whatever the walk speed used to be, multiplied by whatever the booster is, which is 2. Now, let me ask you guys a question. If later on, like 3 months down the road, I want this apply boost to multiply it by 5, what do I have to do? So instead of multiplying it by 2, I want it to multiply it by 5. Yes. All you have to do is change this number to 5. It's so easy because you use this constant. But if we didn't have this variable and I just had times 2 here, if I just had a times 2 here, later on 6 months down the line, I would have to figure out what this 2 represented. And then I would have to change that 2. But now I have a walk speed booster variable. So all I have to do is change this to 3 or change it to 5 and then just publish the game and it's all done. So this is clean code. And here's principle number 2. Functions should always do one thing. Your function should always do one thing. Here's an example of bad code. If you read through it, you can see it's violating that principle. Can anyone tell me what's wrong with that code? You can unmute or you can just chat in premium chat.
It's making too many parts, I guess. There's too many instances.
Yeah, so it's called do stuff, and as we can see, it prints hello, then 1 second later it prints world. And now it's creating a part, and then it's printing just made a part, and then it's making an explosion. It's doing all of that stuff that can just be done separately. And that's exactly what Globe and Nivian said. So yeah, you guys are correct. This is bad because your function is doing more than one thing. You always want your function to do one thing. So now this function is going to get fixed. Boom. Look at how much cleaner that looks. This do stuff, like I'm not really reading much code. I'm just reading what the functions are. If I want to know what do stuff does, I can already tell, oh, it does a greeting, it creates a part, it announces that something got created, and it makes an explosion. And all of those things are separated into these functions right here. So create explosion. If I read this code, the only thing that it should be doing is creating an explosion. And that's what it's doing. So that's what that means. Every function should do one thing. If you have functions that are doing 10 things at once, then it's going to be very, very complicated to read. But as you can see, it's a whole lot cleaner. Create part, all that's doing is creating a part. Announcing part created, all that's doing is just printing that you made a part. Which one would you rather read? Would you rather read this one or would you rather read this one? 1 or 2? 3. I would much rather read 2. It's just line by line, it just tells you what it is, right? So principle number 3 that's given in the book is to only comment when you absolutely need to. Now this might be surprising for a lot of you because you might think, but I thought comments were good. They are. But what happens is comments, they tend to get outdated very quickly. As we're updating our systems, comments tend to get outdated. Here's some bad code. There's a comment that says this function prints hello world. And there's a function called say hello. And guess what it does? It prints hello world. And when you see this, you should be thinking, oh really? This function prints hello world? Your code already told me that, right? Like your say hello, it already told me that the function prints hello world. So why is there a comment that says that's what it does, right? So you don't want, I guess the main conclusion would be you don't want your comment to tell you what your code does. Because I can just read the code. This comment doesn't need to be there, right? So that's one of the points of his book. And the good thing to do about comments is use comments to explain why we're doing something, not what we're doing. Because the thing that we're doing, we can figure that out just by reading the code. But we might not know why we have a test random here. So use the comment to explain why we have a test random here. Yes, why in the world did... So if you gave me this code, I'll see a test random, and I'll be like, okay, so it returns if this function is less than 1. And then if you have a comment here that's explaining it, then I'll be like, oh, that's why you have this function. I don't want a comment here that says it returns if random is less than 1, right? So this comment here, it's actually explaining why we even wrote this. So it says sometimes our random function is giving us a number larger than 1, and that's why I made this function. See how it's using it to explain why it's there? Instead of like, this is a function that does this, you're saying, I wrote this because we needed it for this. So that is a better way to go about writing comments. If you like what you're watching so far, this is a class that I gave to the Premium Scripters Discord community. The community is a Discord community where we host scripting classes every weekend. I help you with all of your scripting questions, we do weekly challenges, and you're guaranteed to learn a whole lot faster than everyone else. Here's some of our stuff that our students have made within just their first month of joining. If you want more classes like these, make sure you join us at premiumscripters.com. Principle number 4, formatting. I'm pretty sure most of you should know this already, but please, please, please don't write all of your code in one line. If you give your script to other people and you ask for help, they're probably going to refuse to help you because it's all in one line. And Roblox automatically indents after you declare each if statement, function, and loop, and you just want to maintain that indentation throughout. So what that means is, this is bad. You have everything written in line 1. You never want to do that. If you ask for help and you give them this, they're gonna chew you out. But this is also bad formatting. We have an if statement. If the speed is greater than 10, then, and we just have all of this code here. It's all unindented. Yep, one-line gun system. So what we want to do is every single time we have a function, we want indentation, which is this space right here. Every time we have an if statement, we want an indentation here. But we don't have an indentation here. So this is how you would fix it. So notice, if statement, there's a bunch of spaces here. In here, if statement, there's no spaces here. We want there to be spaces, basically. And we want that for every function, for every if, for every else, and for every loop. So this is good formatting, but we can do even better than this. We can make it even better, like that. Notice how we completely upgraded it. This power-up checks the speed is greater than 10, then we have game.players and local player, a whole bunch of stuff that I don't want to read, equals speed multiplied by 2, else you print nah. That's kind of confusing. So if you make it even better, it becomes a lot more readable. So now we know that the power-up function, it takes in a final walk speed and the time in seconds. We have a base walk speed of 10, the walk speed multiplier is 2, and we're just checking if the final walk speed is greater than the base walk speed. And then we're just doing character.humanoid.walkspeed equals whatever the final walk speed is multiplied by the multiplier. And then if that's not true, then we just print nah, which is literally, it follows the principle that I had said earlier, which is each function should only do one thing. Print nah, prints nah, right? Principle number 5, error handling. Your code can always throw an error. And what you want to do is you want to try to catch that error and do something with it before it occurs. Here's an example of no error handling. You have a function called teleport player to a destination, and you're using this set primary part C-frame. Yes, this is deprecated, but for now it's okay. And you're just setting the position, the C-frame of the character. Actually, this won't even work. Actually, yes, it will. Yes, it will. And you're just setting the primary part C-frame to the destination. So this will teleport the player to a destination. And then if you have error handling, in here, we're actually checking if the character exists. So in here, the character may or may not exist. In here, we'll know if it exists or not. We check if the character exists. Then you do that. Yep, so warn just makes it an orange. Yep. Any questions? Okay. If you have any questions, you can just interrupt anytime. So this is something that you want to do, error handling. Just make sure that, because in here, this character may not have been loaded yet. So if you make sure the character exists, so we're saying if the character, then do whatever you want to do. And if the character doesn't exist, then we throw a warning. So this is a better way to code. And I'm pretty sure this is the last principle. It's called unit testing. This may be unfamiliar to a lot of us. This was unfamiliar to me even after coding for so long when I read this book. But this is something that you do in Java. And what it basically is you have functions to test to make sure that your code is actually working as you expect. So if we see here, we have a function called is the player's speed boosted? And you have a boost speed. And all it does is it returns true if your walk speed is equal to whatever that boost speed was. So if that walk speed is not equal to that boost speed, then it will return false. So now here's the actual unit test. We're setting the original speed to 16, and we're doing some function that's supposed to increase our player's walk speed to 32. And then this is the actual unit test right here. We're checking if that player's walk speed is actually set to 32 like we want it to, because this line is supposed to set the walk speed to 32, but we don't know if it did that or not. So we're using this assert statement. So this basically makes sure that the player's, this will basically run this function, and then it's going to make sure that the expected output is equal to the actual output. Yes. So if is player speed boosted 32 is equal to false, that means the walk speed is not equal to 32, then it will throw us an error. So later on, like as we're coding, we might update this apply speed boost function. And then what if like later on, we call this apply speed boost 32, but what if instead it sets the walk speeds, it sets the walk speed to like 36? Well, now this assert statement checks if the player's speed boost is actually 32, but it's actually 36 now, and then it throws an error saying it should be 32. So this basically makes sure that your code is working properly. It's called a unit test. So it's just making sure that your code is actually working as you want it to work. We have no guarantee that your apply speed boost will set to 32. That's why we have this line right here, 32. So, yep. Oh, there's one more. Principle number 7, no magic numbers. Magic numbers are any number in your code that doesn't have a variable attached to it. So look at this function. Can anyone tell me what's going on? I see it's returning m multiplied by 9.8 plus 5 times 8. Like, what is going on? It's just doing a calculation. We have no idea what calculation it's doing. It's just there, right? And if you give this to someone and they're reading through your code and they see this, they're like, what? What is this 9.8? What is this 5? What is this 8, right? And the solution is this. Do not use magic numbers. Give them all variables. Now I know exactly what this function is doing. It's calculating a force given a mass. It's just the mass times gravity. This is just the acceleration of gravity plus how much you want to boost the force by multiplied by a multiplier. Wasn't this way easier to read compared to this? So why is it called magic? These numbers right here, 9.8, 5, and 8, we call them magic numbers. So the question is, why is it called magic? And the answer is because suppose you wrote this code and for 3 months you never touched this code again. So you went about your life, you did a whole bunch of stuff. 3 months later you came back and you saw this. And you're like, what? What is this 9.8? What is this 5? What is this 8? What am I thinking? And it's like magic. It's like magic why the number is there. Like you just don't know what it is. It's like magic. Like it's magically there. And we want to avoid this. And to avoid it, we basically just do that. Where you give each number an actual name. And then someone reading it will know, oh, that's what it does. That's what the 9.8 is. It's gravity. Oh, that's what the 5 meant. It's force boost. So just make it descriptive. And remember, use your variables to actually convey your idea. So make sure your variables are actually named properly. So don't call this something that's not gravity if it's meant to represent gravity. It should be obvious to me what your function is doing just from reading the variables and the implementation, okay? So that's the end. And since this is going to be on YouTube, visit premiumscripters.com and join us for more awesome classes every week. Anyone have any questions? This whole presentation is going to be available to you in that class materials channel in the Discord.